Today I'll be walking through 6 core financial programs that provide insights into stock portfolios, technical analysis, bond pricing, stock price trends, asset allocation, and risk assessment. These functions are designed to be simple, efficient, and API independent, meaning they can be used without any stock data source without relying on third-party APIs like Yahoo and Yahoo Finance. These tools allow investors and analysts to make data-driven financial decisions. First one is we needed to create a basic portfolio tracker that once stores stock symbols and quantities list, creates a list of prices and calculate total value, and then use list comprehension to calculate position value. So the first function is called portfolio tracker. Helps calculate the total value of a stock portfolio. It takes 3 lists as inputs: stock symbols, the number of shares owned, and their respective prices. The function multiplies the quantity of each stock by its price and sums the values to determine the total portfolio worth. This tool is useful for investors who want to track their portfolio value manually and use statistic price data for an external source like CSV file or an Excel spreadsheet. Since we are not using an API, this function is highly flexible and avoids issues like rate limits. For example, if we own 100 shares of Apple, 50 shares of Microsoft, and 75 shares of Google, with stock prices of 175.5, 320.75, and 132.40, the function calculates the total portfolio value efficiently, which here is 43,517 with 50 cents. And then the next one is we had to create a simple moving average calculator, which would create a list of historical prices, calculate 5 and 20-day moving averages, and generate signals when short MA moving averages crosses long moving averages. So the second function is called moving average calculator. The calculator that calculates short-term and long-term moving averages for a stock's price history. It takes a list of prices and computes the 5-day moving average and the 20-day moving average using NumPy's convolution function for efficiency. Moving averages are widely used in technical analysis to detect trends. For short-term moving average, 5-day crosses above the long-term moving average, 20-day, it generates a buy signal. If the opposite happens, it generates a sell signal. For example, if we were to provide 21 days of stock prices, the function will calculate the latest moving average and provide a recommendation on whether to buy or sell the stock. And in this case, the latest 5-day moving average from the list of historical prices was 180. The latest 20-day moving average was 165, so the trade signal means to buy. All right, and then moving on, we needed to create a bond calculator that stores bond details, face values, coupon, maturity, and nested lists. Calculate yield to maturity, compare multiple bonds using list operators. So the third program calculates the YTM, helps determine the yield to maturity for bonds. YTM is the total return on an investor can expect to earn if they hold a bond until maturity. This function takes a bond's face value, coupon rate, and number of years to maturity, and the current price as input and computes the year to maturity using NumPy Financial. All right, we store multiple bonds in a nested list and compute the year to maturity for each. The bond with the highest year to maturity is considered the best investment based on returns. This function is valuable for fixed income investors who want to compare different bonds to select the most profitable one. And then moving on to number 4, we had to build a price analyzer. We needed to create a NumPy array of daily prices, create daily, weekly, and monthly returns. All right. So the fourth program has a price analyzer function, which we created, focuses on stock price, trends, and returns calculations. It takes a NumPy array of daily stock prices, computes 3 types of returns. Daily returns measures percentage change from previous day's price. Weekly returns compares prices over 5-day period, and monthly returns, if enough data exists, it calculates a 21-day return, simulating a full trading month. Additionally, the function identifies the highest and lowest in the data set and their positions, which is useful for understanding stock volatility and trend analysis. This function helps trade analyze stock movements over time. All right, and then we scroll down, we can see the next one is an asset allocation tool, which stores current and target allocations in arrays, calculates allocation differences, and determines rebalancing needs. So the fifth program, asset allocation, helps investors maintain a balanced portfolio. It compares an investor's current allocations to their target allocations and identifies the necessary adjustments to rebalance their investments. By using NumPy arrays, we can efficiently calculate allocation differences and generate buy, sell, hold signals. This is essential for investors following a disciplined investment strategy. For an example, if an investor who wants 30% of their portfolio in stocks, 30 in bonds, and 40 in cash, but currently has 35 in stocks, the function would suggest selling some stocks to rebalance. All right, and then we scroll down to the last question is to create a basic risk calculator which stores historical returns in NumPy arrays, calculate correlation between assets, and compute portfolio volatility. The final program, which we created, is called the Risk Calculator, focuses on the portfolio risk assessment. It takes historical stock returns and calculates two key risk metrics. So one, correlation coefficient, measures how two assets move relative to each other. A correlation close to 1 means the assets move together. A correlation close to -1 means they move in opposite directions. A correlation near 0 means they are independent of each other. So the second thing is portfolio volatility, computes the overall risk level of a portfolio based on the standard deviation returns annualized for 252 trading days. This function helps investors determine whether their portfolio is well diversified or if they overexposed to certain risks. By analyzing correlations, we can ensure that assets are not too closely linked, which could increase risk during market downturns. So, in summary, these 6 programs provide a strong foundation for financial analysis using Python. They enable users to track their portfolios, analyze price trends, compare bonds, manage asset allocations and risk, all without relying on external APIs. The flexibility of these functions allows them to be easily adapted for real-world applications, including portfolio management, investment research, and financial modeling. Thank you, and I'd be happy. Thank you, and I hope you have a great rest of your day.